pretty much defined the trigonometric ratios. The next thing to do is to talk about the angles. Let's scroll down. When we talk about, for example, sine x, one thing that needs to be remembered, there is no such thing as sine. There is no such thing as sine. It has to be always followed by an angle, because this sine, the full form is sine, S-I-N-E. So to find the sine ratio of an angle, if there is no angle, then there is no sine ratio, because the angle is the reference to the opposite. So it is the reference to the opposite side. So if you don't know what the angle is, you don't know what the opposite side is. So whenever anything is said without the angle, it is wrong. Similarly, when you refer to cos x, it is to find the cosine ratio. So to find the cosine ratio of an angle, and that angle is going to give you the reference to the adjacent side, because the hypotenuse is always fixed. So the angle is very, very important. Now let's talk about the angle. The definition of an angle is, if we have two lines here, this line and this line, the definition of an angle, we can have many arcs here, we can make many. So it doesn't really mean that the bigger the lines are, the bigger the angles. No, the definition of angle is the smallest space between two lines. Smallest space between two lines, that's the angle. Now previously, if you think about angles, it was actually figured out by the farmers. They would look at the sky. So in a night sky, the sky would actually look like this. If you think about the sky, it would look like something like this. So if this is the night sky, it looks like a circle, and suppose there is a star, and that star looks like this. There's a star here. Now what would happen? Every day the star would move, because with the rotation and the revolution, if you think about the revolution of the earth around the sun, so it would appear as if it's moving away like this, and it looks like this. Now there are around 365 days in a year. So in those days, what they would do, they would actually be counting the positions for the next harvest, and from that they could figure out the position of this all the way up to here. So every day would be like a degree, so they call it 360 degrees with respect to the 365 years. So to simplify things, actually they were pretty good at it, so this is for convenience. So 360 degree means every movement. So if we break this down into small degrees, we can think of this as 360 degrees. So the angle, the degrees measurement came from there. So if you break it down into 4 parts, each one can be called a 1/4 or a quadrant. That would make the calculation of the angle, no matter how big the angle is between two lines, it can never be more than this. If it is more than this, it means we are rotating again. So the same position will always have the same ratio. So if someone says, if this is measuring from here this is 30 degree. If you rotate here 360 degree and you come here 30 more, so one rotation is 360 degree and 30 more is 390 degree. So the sine ratio of 30 degree and the sine ratio of 390 degree is the same because the position is the same. One more thing that must be mentioned is the concept of similarity. If we have a triangle like this, if this angle is say theta, it can be any angle, it doesn't matter what the triangle size is. If you extend this and draw a bigger triangle, if you extend this and draw the bigger triangle, if you extend this and draw a bigger triangle, by the concept of similarity, the ratio of the sides are the same. Doesn't matter if it's like this, this is AB, this is CD, this is EF, and so on. Doesn't really matter. The ratio of, if I talk about this same theta, the theta is the same. So it doesn't matter how big the triangle is, the ratio is the same. So if you divide the opposite with the hypotenuse, that value will always be the same. So the calculator will always have one value of sine 30 degree. It will always be fixed, which happens to be half. So the value of the angle doesn't matter how big the triangle is, it doesn't change, so it's always fixed. So the sine ratio and the cosine ratio, all the values are always fixed. It doesn't really matter how big or how small the triangle is. Now some of the most common angles that we measure, they're actually this is how we can measure it. These are the common angles to measure. Common angles. So these are, if you make a quadrant, 0 degree, 90 degree, 180 degree, 270 degree, and this position and 360 degrees the same positions. Now if we think about it, this is sine of a 0 degree is 0, and if you come to the other side, sine ratio of 180 degree is also 0. Since this is 0, this is also 0. Similarly, sine ratio of 360 degree will also be 0. Now sine ratio of 90 degree is going to be 1, and sine ratio of 270 degree is equals to -1. So sine ratio of 0 degree is 0. Here sine ratio of 180 degree is 0. Sine ratio of 90 degree is 1, and opposite that sine ratio of 270 degree is -1. And don't forget, 0 degree and 360 degree has the same position. That means sine ratio of 360 degree is also 0. This is something you need to memorize. Similarly, here the opposites are going to happen. Cosine ratio of 0 degree, since sine ratio is 0, this is going to be 1, and 1 in the other. Cosine ratio of 180 degree is going to be -1. Since this is 1, on the other side is going to be -1. Sine ratio of 90 degree is 1, so cosine ratio of 90 degree is 0. Similarly, cosine ratio of 270 degree is also 0. So 0 opposite 0, -1 opposite 1. So this is how it is working. So this is something that needs to be remembered. This is very, very important. So we can think of this: sine 0 is 0, sine 90 is 1, so cos 0 is 1, cos 90 is 0. Similarly, sine 180 is also 0, and sine 180 and sine 270 is -1. Similarly, cos 180 is -1, cos 270 is 0. So this is how this is working. So these are some of the common angles. Now two more angles are very, very important. So let me come to this side. So these are, first of all, let me write this down. Sine 180 degree is also 0, and sine 270 degree is -1. Cos 180 is -1, 1 opposite -1, and cos 270 degree is also 0. Now let's talk about some more common angles. One of them is the 45 degree angle. Now for the 45 degree angle, let's take a look at here. Take a space out here. So for the 45 degree angle, if you take a look at that 45 degree angle, what we have to think of, what is sine 45 degree? The best thing to do is to think of a right angle triangle which is also isosceles. So if this is 90 degree and this is equal, so if this is 1 and this is 1, by Pythagorean theorem this would be square root of 2, and this angle is going to be 45 degree. Similarly, this angle will also be 45 degree because its isosceles base angles are equal. Now when we talk about the sine ratio, sine 45 degree is opposite, because reference is always the angle, opposite by hypotenuse. So sine 45 degree is opposite by hypotenuse. Similarly, cos 45 degree is also going to be opposite, here it's adjacent by hypotenuse. And for tan 45 degree we are going to get opposite by adjacent 1. So that's another common angle, which is 45 degree. And one more, the last one that I want to talk about, that is a 30 degree 60 degree angle. So this is, we can consider a triangle like this, where you can consider this actually half of an equilateral triangle. Suppose this side is 2, then this side should be 2, so half of that is going to be 1, and by Pythagorean theorem this is going to be square root of 3. And in an equilateral triangle all the angles are 60 degrees, so this would be 60 degree and this would be half of 60 degree, which is 30 degree. Now if we think about it, for this one, sine 60 degree is going to be opposite by hypotenuse, so sine 60 degree is root 3 by 2. Then we have cos 60 degree. Cos 60 degree is going to be adjacent by hypotenuse, which is going to be 1 by 2. Similarly, we can find 30 degree. Sine 30 degree is going to be opposite by hypotenuse 1 by 2, and cos 30 degree is going to be adjacent by hypotenuse, which is going to be root 3 by 2. Root 3 by 2. And of course we have tan also, so we can consider it here tan 60 degree as opposite by hypotenuse, so this would be root 3 by 1, which is root 3, and here tan 30 degree is going to be opposite by adjacent, which is going to be 1 by root 3. So these are the trigonometric ratios of some common angles. It is very helpful if someone memorizes that, because then you don't have to go back and forth to the calculator and get the values of the trigonometric ratios and how they come about. So you have to remember, doesn't matter how big the triangle is, the trigonometric ratios of a particular angle is always fixed. The next thing that needs to be talked about is the radian measure. It's much better to do the calculation of the angle using the radian measure rather than the degree measure. So the next thing would be, best thing to understand is the radian measure.